Hello class, it's Mondragon here, and today we are going to be going over scatter plots. So your objective is that you're able to find the line of best fit from a scatter plot. The essential question for today is, what is the line of best fit used for? So keep that in mind as we start our vocabulary. The first word, of course, is scatter plot. And a scatter plot is a graph that shows the relationship between two data sets. So let's take a look at this example. So if you notice, I'm talking about the ages of American women at first marriage. So the first thing I want to look at is the title, so I know what I'm talking about. I know that I'm talking about the ages of American women when they first get married. And my x-axis here is talking about the years. So I'm starting at 1960 and going all the way to 2010. And then for my y-axis, I'm looking at the age of the women, and it starts way down here at 18 up until 28. Okay, so if you notice in 1960, I started up at 20 years old. Okay, so in 1960, the average age for women to get married was 20. And then as we move along in the right direction, up until 2010, that is increasing. So this right here would be known as a positive scatter plot, okay? Because what's happening is, as the years increase, because we're going to the right, the age of the women is also increasing. So in conclusion, as the years increase, the marriage age for women increases. That's what we get from this scatter plot. And it's a scatter plot because it's not a perfect line going up, okay? But it is still going up, okay? It's scattered because this is real data. And real data is not perfect like we've seen in the first semester of Algebra 1. Okay, for our next vocabulary word, we have correlation. What is a correlation? A correlation is a relationship between two data sets. So when we ask for the correlation, we're asking for the relationship between the points. So you can use a scatter plot to describe the correlation between the data. We have three types of correlations. We have positive correlation, negative correlation, and no correlation. So let's begin with this first example. If you see, this is a positive correlation, because looking at the scatter plot, these points are going up. So that right there is positive. What we would say is X is increasing because it's going to the right, and Y is also increases. So the relationship is that as X increases, Y increases. So let's take a look at another example. A negative correlation. If you see these ordered pairs here, this scatter plot is going down, so that's why it's negative correlation. Now, the X, if you notice, it's still going to the right, so X is increasing, but on the Y-axis, the points are going down, so Y is decreasing. So that's why this is known as a negative correlation. Or you can have no correlation, where if you see these ordered pairs on this last one here, they're all over the place. They're not going in a straight line down, they're not going in a straight line up, they're not even going anywhere. They're all over the place. So when you see that, then there is no relationship between the x-axis and the y-axis. Okay? So those are the three types of correlations you can have. Our next vocabulary word is the line of best fit. A line of best fit is a line drawn on a scatter plot that is close to most of the data points. We also call that our trend line, okay? And our trend line, our line of best fit, helps us find and predict data for things that we don't see on the graph, okay? So let's take a look at this graph that we have down here. I'm going to make a trend line, and this line needs to go in between these points here, where I want a little bit of the points on each side of the line. So sometimes it takes a couple tries, but I'm going to see how I do here on this first try. Okay, so I did a trend line. I made my line go in between my points. And let's see how many points I have on the top of this. So I have 1, 2, 3, 4 points on top of the line. And then at the bottom I have 1, 2, 3, 4, about 4 points at the bottom as well. So that looks like about it. I might want to move it down just a little bit. So I'm going to redo this again. About right there. Okay, so I think it needs to go up a little bit. I want this trend line to go right in between these points. Okay, so there's my trend line. It took me a couple tries, but I finally got a trend line that has points on both sides, about half the points on the top of the trend line and half the points at the bottom of the trend line. Now, what that trend line is going to help me do is make predictions. So if you look at the sugar in grams here, and I go to 58, if you look, there is no point on 58. But I can go up to my trend line and make a prediction that will have about 275 or something. So if your smoothie has 58 grams, we're going to predict, using that trend line, that it will have somewhere between 270 and 280 calories. Okay, so that's what our trend line allows us to do, make a prediction. Of course, your trend line needs to be well drawn. Sometimes it takes a couple tries. I like to put my pencil on it and use that to help me draw a better trend line. Okay, so let's take a look at some examples. First of all, we're going to describe the relationship of the data for the scatter plots below. So we're going to take a look and describe the relationship. What kind of relationship do we have? Positive, negative, or no relationship? So looking at the first one, we're talking about Honda cars. And the age, let's take a look first at the age at the x-axis. So we're talking about the age in years. And the y-axis is talking about the value in dollars and thousands. Alright, so looking at this, if you notice, this is going down. But these points are not tightly close together. So we would call that a weak negative correlation. Still negative because it's going down. You can also call it a trend. So this first example has a negative correlation, but it's weak because the points are kind of scattered about, but they are all still going down. So it's still negative, but it's weak negative, okay? Now, we want to know the relationship between the years. So what is happening to x? Well, as x is going up, it's increasing. If you notice, it's going to the right. In other words, as the age increases, as the age of the car increases, if you look at the y is going down. So the value of the car decreases. Okay, and just to make sure we've done this right, does this make sense? Well, as your car gets older, as it increases, the age of it increases, is it true that the cost of it, the value of it, decreases? Especially for Honda cars. Yes, that's for most cars, okay? That's what's going to happen. Alright, let's take a look at ABC Company here on the side. I have the x-axis talking about the hours worked, and the y-axis is talking about the amount of dollars earned. Okay, so let's take a look at my points. My points, if you notice, are going up. So that means that it's a positive correlation, and we need to decide if it's weak or strong. Well, looking at these points, they're all very close together. So the tighter they are, the stronger they are, okay? So this would be a strong positive because it's going up and the points are tightly close together. If you notice, you almost don't see any points when I put that line over it. And because it's positive, that means that the x is increasing and the y is increasing. So I would write that as the hours worked increases, the amount of money increases. Okay, so looking at this, does this make sense that the hours that you work increase, the amount that you make increases? Of course that makes sense. Okay, the more hours you work, the more money you will make, especially on an hourly job. Okay, for these next three at the bottom, I'm not going to go into that much detail. I'm just going to talk about the correlation. So looking at this very first one, we're talking about the person's age and the number of vehicles that they own. Okay, so if you notice, my points aren't going up. They're also not going down. In fact, they're kind of all over the place. See, if I draw a line there, I can't draw a line there. See, I'd be making lines all over the place. So, when this happens, this is called no correlation. Now, this is called no correlation because there's nothing going on here. The person's age and the number of vehicles that they own have nothing to do with each other. Okay? This is saying that the age that you are has nothing to do with how many vehicles you've owned. And that's true. How old you are doesn't mean that you're going to own more vehicles, okay? So there's no relationship here. I would say that there is no relationship between the age, your age, and the number of cars that you own. So there's no relationship between the person's age and the number of cars owned. So let's take a look at our next example here. We're talking about the average daily temperature and the cost, the coat sold per day. Alright, so first of all, I notice these points are going down. So this would be a negative correlation. And these points, because they are kind of closer together, I would say that this is a strong negative correlation. Because the temperature outside is increasing, and as the temperature is increasing, the coats that they sell is decreasing. Well, that makes sense because the hotter it gets, most likely the less coats you will sell. Okay? Alright, so let's take a look at this last one just to see what kind of correlation we have. These points are going up slowly, but they're going up. So this would be a positive correlation. Okay, for this last example, the scatter plot shows the total fat in grams and the total calories in 12 restaurant sandwiches. So let's first analyze this graph. We're talking about the fat in grams of the sandwiches and the calories that the sandwich has. So we want to know about how many calories are in a sandwich that contains 50 grams of fat. So I want to go to 50 grams of fat. The grams are here on the x-axis. I'm going to go to 50. Well, if you notice that's going up 40, 45, 50 will be right here. And there's no point there. So what I need is a trend line to help me predict about. That's why we have that keyword about. So I'm going to make a trend line here that goes in between these points. Remember, I want to have about half of the points at the top and half at the bottom. And drawing my trend line looks pretty good. Now I'm able to go to 50, go up to the trend line, and it looks like it would have about 800 calories. So my prediction would be about 800 calories. And I used my trend line to help me find that, help me make a good prediction, because there's no point on 50. Alright, let's now go to the next question. How many grams of fat are in a sandwich that contains 450 calories? So this time I want to go to the calories, and I want to go to 450. And if you notice, there's no point on 450. So I need to go to the trend line, go down, and find the grams. And it looks like it's somewhere between 15 and 20. So I'm going to say between 15 grams of fat. So it's between 15 and 20 grams of fat. Okay, so a trend line helps you make predictions on a scatter plot. Okay? Have a good night.